Well, good morning, everybody. Welcome to our presentation today by Lina Hockaday. We are very glad to see that the high interest level, and this especially is a topical area of discussion. Lina is a very passionate researcher in this field, and it's always lovely to see a researcher who is passionate about her field, but it's backed up with really good science and an in-depth understanding of the industry and how things are interplay in this area. Lina is a senior engineer at Mintek, and her key areas of research is specifically in renewable energy and applications and integration thereof in the minerals and mining industry. Lina, while I'm introducing you, you can get ready to put up your presentation and present to us today's talk. To our attendees, if during the presentation, if you have questions, you'd be welcome to use the Q&A section at the bottom of your screen to type in questions. If at the end, if there's interesting questions, we will facilitate those questions with Lina and we can discuss all the interesting aspects around this topic. You can also welcome to use the chat function to make comments while she's chatting. Lina, thank you very much for your time this morning and enlightening us on this very topical area of discussion in the mining and minerals industry today. Please go ahead.
Thank you, everybody. Welcome to this webinar. I have a very informal style of presenting. I hope it suits the audience. So today's topic is CO2 mitigation and carbon tax strategies for mines and minerals processing in South Africa. And I'm going to keep it quite general. If you want to go into the deep technical data, then send Sahim messages and ask them to organize a second webinar on the technicalities of a certain topic. I would love to do that, just by the way. Okay, so so I work for Mintek. Mintek is a government-owned minerals science council, and we do research, and we do it for our country. And we employ about 700 people, 250 professionals. Our annual budget is around about 500 million rand, and we aim to get that balance between state and corporate funding. So, but what gets me really excited is our mandate, and that is to serve the national interest through research, development, and technology transfer, and to foster the establishment and expansion of industries in the field of minerals and products derived therefrom. And then you can see some great pictures of our pyrometallurgical test facilities where I started as a young engineer. Okay, but today we are talking about CO2 emissions targets, and we are talking about strategy and also about mitigation and all of that. So let's review quickly where our targets come from and why they are needed. Climate change and global warming is really real, and it is more and more becoming apparent that action is needed sooner rather than later. So you might be aware of the Conference of Parties in Paris in 2015, where they set the target to keep global warming below 2.5 degrees Celsius and preferably below 1.5 degrees Celsius. So context there is we're currently at 1 degree Celsius global warming. So there's not a lot of wiggle room on CO2 emissions. But, you know, are these 2 degrees, 1.5 degrees, are they based on science? Yes, these targets are based on scientific agreement. And that's why 195 countries in the world said we will try and meet these targets. But when it came to setting the tasks for each country, nobody wanted to enforce something on anybody else. So each country was asked to volunteer their national designated commitments. And that was done. And that was a great positive step for fighting climate change. But when you total up all the commitments, it came short of what was needed to reach the 2 degrees Celsius target. But these targets are being reviewed currently, and South Africa needs to decide on their new revised targets before the end of the year. So this is a year that if you want to see these targets on emissions changed, then you must campaign now and be an activist. Okay, so this is a visualization of South Africa's target, and South Africa's strategy from 2015 was to say we will first stabilize our emissions and keep them roughly the same, so rather than increasing them, and then we will reduce CO2 emissions, and we will try and reduce them to about half by 2050. Okay, so how do we evaluate this? So you can go to the website and you can see what the Climate Action Tracker does. They look at each country's targets and they say, if every country in the world followed this strategy, where would we end up on global warming at 2100? And if every country in the world did targets like South Africa, then we would end up at 4 degrees Celsius global warming. So, of course, there are different influences and factors that goes into setting a strategy for a country. We are a developing country. We do want to develop. We want to grow our economy. And sometimes there are some CO2 emissions linked with that. The job of research and science, of course, then is to try and find ways that we can unlink that we can grow and develop economically while lowering our CO2 emissions. Okay, but this raises concerns. Okay, so countries have different strategies for lowering their CO2 emissions. Some countries have carbon taxes. Some countries just put stronger emission limits. So what happens to the mine or mineral processing company when you are competing in a global market, but your competitor does not have to pay carbon tax and you do? So of course, if you don't pay carbon tax, then your price that you can charge, you can probably maintain your profit margin and you can have a lower product selling cost. But if your country has very high carbon taxes, you probably have to pass that along in your product price. You're not so competitive. And that's why many countries are saying, if you impose carbon taxes, then everybody has to impose carbon taxes so that there's a level playing field. And this is still under negotiation. This is what our climate change politicians has to fight for. But we have to support them in their fight so that we are not compromising our growth potential by the carbon taxes that we need to impose to get the emissions down. So definitely there has to be some kind of price to this emission if we want to protect our environment. And this has led to now 46 countries in the world either having carbon taxes or an emissions trading scheme that incentivizes companies to reduce CO2 emissions. And China is one of them. Okay, so when you look at CO2 emissions, first of all, you look scope 1. You look at yourself, your company with its borders, and say, what do we emit directly on site? Okay. And when you look at that, you try and do improvements. When you look at the second scope, you look at, okay, but I'm also buying things in. I'm buying electricity. How's this electricity generated? What are the CO2 emissions that are being emitted by that? But now that's not enough. We have to look even wider. We have to look at our products are being sold to somebody else. what if they use it in a process that generates a lot of CO2 emissions? And the whole value chain, whether it's owned by one company or not, is being scrutinized. And we have to, when we make changes, take that into account. Sometimes it's not just a challenge, sometimes it's an opportunity to engage either a supplier or a customer in your plans to protect yourself against this carbon tax or use it as an opportunity. But you will be, if you're a company trying to reduce your emissions, you will sometimes be faced with a lot of skepticism, like Dilbert's boss. Like, are you really committed to this process, or are you trying to do it just as a public relations exercise? Okay, so let's look at the example of Rio Tinto. Rio Tinto, in their climate change report last year, they stated their ambition to reach net zero carbon emissions by 2050. Okay, so that's 50 years from now, 50 years to go to net zero carbon emissions. So to reach that, they want to reduce the emissions intensity. That means the amount of emissions per ton of product, for example, by 50% by 2050, and they want to reduce the absolute emissions by 15% in the same year. Okay, so to do this, they've invested $1 billion on climate-related projects over 5 years. And they aim that in future, when they grow, they will grow in a carbon neutral fashion. Okay, so as a process engineer and somebody who's done industry research most of my life, I looked at this and I thought, wow, that's really ambitious, that's really awesome, you know, way to go, Rio Tinto. But what was the media reaction? They said, your plan does not address scope 3 emissions. We are not happy with your plan because you didn't look at your total value chain. Okay, so that shows a bit of the social factors that are impacting on companies when they try and reduce their CO2 emissions. So let's look at the things that you can do to reduce your CO2 emissions and other greenhouse gas emissions. And most of you might be familiar with the sustainability and recycling R's, the 6 R's: reduce, reuse, recycle, rethink or reinvent, and refuse. So reduce, we try and reduce our emissions. Reuse, we try and never throw something away. We try and reuse it as often as possible. Recycle, if you cannot use it anymore, can you break it into components and use those components again? Rethink, reinvent, can this be done in a different way? Do we have to generate pollution? Refuse, just to say, I am not going to do this because the cost on the CO2 emission side is too high. I will refuse to do it. Okay, and on the right-hand side is the type of terminology that's often used in the research industry and in when you read about the projects. Talking about energy efficiency, that's reducing emissions. Carbon capture and sequestration, that will be refusing to emit it, you're capturing it. Use is to recycle. Electrification, you replace your carbon with something else that hopefully has a lower emissions profile. Hydrogen is also a replacement. Renewable energy sources can maybe be said to be a different way of doing it, but it's also a replacement strategy. Energy storage is, you know, it is one of those things that comes into using it as efficiently as possible. Sometimes you can generate so much electricity that you can't use it all at once, so store it and use it later. And then offsets. Offsets is the terminology we use when you cannot limit your CO2 emissions anymore, so you will limit it somewhere else to offset your emissions. One of the easiest example to use is planting trees that reabsorb CO2 from the atmosphere to counter the emissions that you are giving to the atmosphere. But these days you can even have a project where you capture CO2 from the air and store it, that might be more economically feasible than capturing your emissions directly from your process. So there's no right answer, one right answer for everyone. All these technologies has to be evaluated for each company, for each location, for each specific value cycle, So people have often asked me, what's the benefit of carbon capture and reuse? So I'm trying to explain it on the hand of this diagram. On the left-hand side is the original business as usual case, where we take carbon, we use it in our process. Usually it turns into carbon dioxide and it gets emitted to the atmosphere. So on the right-hand side is the capture and use case, where the same thing happens, but instead of going to atmosphere, it gets captured. You then use additional inputs to convert it into a fuel or product. That's usually energy, water, that gets added depending on the product you want to create from it. And then you use it in another process, and then it can either be captured again or emitted to atmosphere. So the benefit for carbon use is that instead of directly being emitted to atmosphere, your carbon atom gets another cycle of use, and that replaces a carbon atom that might have originally come from fossil fuel derived fuels. So you still eventually send the carbon atom as carbon dioxide to atmosphere, but at least you've done more with it. And that is the rationale for supporting carbon capture and reuse applications. Okay, so it sometimes sounds very, very difficult to change our emissions patterns, but one of the easiest ways to do it is to change electricity source. And this is a graph from the Rocky Mountain Institute, published 2 years ago, and it shows how several mining companies who use a lot of electricity, you can see the scale of electricity used on the right-hand side of the graph, but depending on your operation, you can quite often replace quite a lot of your electricity with renewable sourced electricity. So that's definitely also an opportunity in South Africa, where we have such brilliant resources of solar and wind. Okay, so your hedging strategy against carbon tax. You are emitting carbon. Now what? Okay, I cannot give you a direct answer, as I said. So it needs to be evaluated for your unique situation. And please recognize that most solutions will have a few challenges around them. You might have to tweak it. You might have to engage some experts. Sometimes things do not work directly off the shelf. But if you go look at your value chain, if you go look first on your site and then talk to your suppliers and to your customers, I think that you will find that there are many opportunities. And sometimes I think there's too many, and it's difficult to decide which one to pursue first. But a high-level opportunity assessment will often help with that. And then often it is the project might be too large for your company. If you are one of those big companies that can spend 5 billion or 2 billion or even like 20 million, then you might be able to do your project on your own balance sheet. But most often renewable energy or process changes, both of these type of interventions are capital intensive. You will have to buy, change, do a lot of capital intensive process steps. So it's important to identify who are the partners that want to help you to do this. And as I said, they can come from your value chain, they can also come from government, or they can even be global funders for renewable energy projects. And usually, if it's a big project, the first step would be trying to get funding for a feasibility study. And if that's successful and you're sure that this is something that will actually protect you from carbon tax, or it will protect you from being liable for some environmental, shall I say, legal actions, and you want to go ahead, please remember, evaluate your technology and see where it is at the moment. If it is already commercially out there, like a solar PV panel, it's out there. There are millions and tens of millions and so many out there. You don't need to pilot a solar PV panel. That you can go to implementation probably directly. But if your technology is something like a new process of carbon capture, you need to go through the proper steps. You have to evaluate if you need piloting. You have to evaluate if you need demonstration at a larger scale. It's very important to ensure that when you implement it in the end, it is the appropriate solution for your company. Oh my goodness, I just jumped to the end of my presentation, unfortunately. I apologize. Good. So what are the type of business strategies that some companies have done? Some companies, mining companies, have said, we are not going to mine fossil fuels anymore. We are going to change to the raw materials for the zero carbon economy. We're going to rather try and mine for battery inputs, for materials that goes into battery manufacture, for materials that goes into wind turbine manufacture. So you can change the way you do business. It is difficult, has costs, but this is definitely a hedging strategy for the future. So if you see the changes coming, you cannot continue business as usual. This might be a strategy to consider. You can also change your operations. One of the most expensive fossil fuels is diesel. If you have diesel generators on your plant or in your operations, these would be the first things that I would recommend that you try and change, because there are alternatives that can reduce their use or sometimes even completely replace them. And that would save you expensive diesel, and it will actually reduce your carbon footprint. So that's a win-win situation. Also, look at your value chain again. Ask your suppliers about their emissions. Sometimes, if you can influence them to reduce your emissions, it reduces your scope 3 emissions. So we need to take responsibility for our whole value chain. And use incentives that are there to change to the best advantage. There's an offset allowance for carbon tax in the South African carbon tax. Make sure you understand what offsets are available and which one are applicable to your industry. There's the 12L tax incentives for energy efficiency, where you get like a 95-cent tax rebate for every kilowatt hour on energy saved. I hope you already knew about this, and I'm not the first person to tell you about them, but be aware of the measures that are in place to help you change. And then invest in research. Okay, so we heard about Rio Tinto. Here's another case study, the hybrid project in Sweden. It is a project that will make steel using hydrogen as reductant instead of carbon. And the industrial process is scheduled to be completely operational by 2030, just 10 years from now. So the total cost for the pilot phase is estimated to be about 2.6 billion rand. And to date, 2.4 billion have been invested in this project. You can read about it on their website. But this project will, when it's done, it will reduce the whole of Sweden's emissions by 10%. Okay, so this is a very exciting technology. But of course, the first thing, if you talk to steel producers in other countries, they say, oh, well, that's fine for them. They've got a government that's co-investing. They've got, you know, they're a rich country. How can we do it? And it comes to that level playing field. Maybe it would be possible for us to do it if carbon price was high enough. Okay, there are some boundaries and constraints in South Africa. We all know that the NERSA application process for like for electricity generation for more than 1 megawatt is actually quite, it takes a long time. And we know that government is trying to look at it. We are all waiting to see how that will play out. Will it change? Will it become faster? Will they relax some limits? And then there's got some confusion about what happens with power supply contracts that are not supplying to Eskom, but supplying to a consumer directly. In the IRP, there was sort of like some sentences that you could take as saying that this would be acceptable to have like a power supply company supplying to your company as long as it's not grid connected. But not being grid connected can sometimes also make the renewable energy more expensive because it needs more storage, it needs more backups. So this is some of the constraints that we have to work in. Economic environment at the moment, we all know it's tough times, and it's predicted that our economy will shrink, the global economy will shrink. And so, of course, talking now about changing processes, about capital investment, it's a bit tough. And then also there's sometimes technology limits. We know about the renewable energy, it has a variable source. The sun doesn't always shine, the wind doesn't always blow. We have extra storage systems that can help manage that. It brings greater complexity to the energy system. It is not just Eskom will look at that and we don't have to worry. If you have it on your site, you might need to know how to control and manage this optimally for your process. And there's globally a lot of uncertainty. I just added the graph for the oil price over the last most recent months. Nobody would have predicted this graph in November or even December. So it becomes more and more important to do our techno-economic assessments. They are the only things that can try and help us get a handle on all these complex issues. So, but there's enablers. So with the tough economic situation, we have like a very low interest rate environment. In fact, the repo rate in South Africa is now at the lowest level since 1973. And in the European Central Bank, Japan and Switzerland, they actually have negative interest rates, which means they will pay you so that you can borrow money from them. It's actually a very strange situation to be in. So if you can get, you need to make an investment in capital heavy project, then now you're probably going to get the best interest rates that you're going to get in a long time. We also have a lot of funding for green initiatives available in South Africa. So a research company undertaking R&D in South Africa qualifies for 150% tax deduction of its operational R&D expenditure. So if you can do your own R&D, or you can do maybe R&D with a South African institute, maybe this can be of benefit to you. I also want to recommend you to go to Green Cape website. They're a company that's very active in supporting green initiatives in South Africa, and they have a database of all the government and institutions that have financing options available for renewable energy projects. So you can go on there, and it's really a very nice summary of who supports what. Will they be able to give you a grant or loan or preferential rate? It summarized all of these very nicely. And please don't forget our academic institutions and science councils in South Africa. I must say that the researchers in South Africa are often underestimated. There's some really, really smart people in South African universities and South African science councils, and they really would love to support your research into process changes or CO2 mitigation initiatives for your company. Okay, so there's an example of some of the funding that I think is underutilized. I'm going to raise the Green Climate Fund. So the Green Climate Fund is the fund that's generated by the Conference of Parties, all 195 countries that have set the targets for climate change. And this fund is at the moment at $5.6 billion US. Okay. If you go to the country profiles under the fund, and you can do that for all countries, you'll find that there's 5 projects in South Africa. 4 of them are multi-country projects, and only 1 of them are specific to South Africa, and it is about the funding renewable energy and climate change projects. So I do think that if we go look for funding, and for funding that comes at not too high a price, it will be available. So allow me to close my presentation with some examples of the opportunities that we've identified. So I must say that I mostly work in the solar thermal space. So this is where the examples are going to come from. When I started thinking about which renewable energy options am I going to research, solar PV, in my opinion, it was too advanced. I couldn't pick up on all the research that's been going on. I wanted something that didn't have as much industrial application already. So I picked the solar thermal, which is for process heat applications. And then also I tried to avoid electricity applications too much because of the constraints on new self-owned generation facilities, and the way it's difficult to get them off the through regulations. So I looked at where all our major mineral resources are, and I superimposed it on a solar map. And because I was already familiar with some manganese processing, that's where we picked our first project. You can see that the manganese and iron fields in the Northern Cape have quite good solar resources. We also did a bit of a roadmap, and we identified other opportunities for solar thermal applications in minerals processing. And they vary a lot from preheating and with solar thermal energy to reduce diesel consumption. We would really love to have some projects going on scrap remelting and casting for low melting metals, thinking zinc and aluminium. So hot dip galvanization is an example of zinc as a low melting metal. There's several hydrometallurgical processes where you need low temperatures below 400 degrees Celsius that could easily be supplied by solar thermal. There's some things that we are maybe stretching a bit. Zinc distillation requires like 1000 degrees Celsius. Solar thermal, if you look at technology options such as a particle receiver and particle thermal storage, it's on the brink of achieving that temperature barrier, that technological barrier. And then copper electrolytic refining, there's already some commercial applications of that in Chile and other countries. Electrowinning of manganese metal, there's a company in Australia that's actually also going to be using renewable energy in the electrowinning of manganese metal for battery grade manganese oxide. And all these type of facilities, and this is not an exhaustive list, it's some of the things that we think could help revitalize South Africa's ferroalloy industry and foster industry growth. We are doing some international projects. An example of this is the Prima project, where we have moved a weather station to TransAlloys. The idea is to see in eMaghleni what's the potential for solar thermal plant to do preheating of manganese ores before smelting them. And this station will help us to get data on that. It's actually part of the South African University Radionomic Network, and the data is available online. You can actually go to the link and go look at the Mintek Elandsfontein station and see exactly the environmental conditions at TransAlloys. And this is the support of also breaking barriers between renewables industry, such as will the mirrors that we use in solar thermal, will they be too dusty? And we have a project investigating that. This is the camera setup that looks at the mirrors, and we are very excited about the data coming out of this. It's also going to be very useful in how dust moves around the plant, which also has implications on your safety and health and environmental control. So I think this project will be very interesting as it goes to its conclusion in the next 2 years. We also do some fundamental research on, okay, so say now we replace carbon as a heating source with hot air that was produced at the solar thermal plant. So this hot air doesn't have CO2 emissions, it was heated with solar thermal, but what changes does that mean for my process? First of all, it is no longer a reducing heating process, it's now an oxidizing heating process. And some of our initial results in the Prima project indicates that a process like this will actually increase the overall energy requirement of the process, but it reduces the carbon requirement more than expected, because some components that would have reduced by reacting with carbon now gets reduced just by thermal decomposition, so there's no carbon needed. So these are very interesting discoveries that you do once you try start and investigate the changes in processes. I would also like to highlight a paper we wrote for the Prima project on comparing different locations of projects. In renewable energy, it's always location, 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 but then also pilot, 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 I have to say that. We compared a location in China, one in Spain and one in South Africa, with different solar resources and different grid electricity prices. This is the grid electricity price for China, expressed in US dollar per megawatt hour. You can here see similar information for the location we picked in Spain. And you can see Spain has a very high electricity price on the grid. And then we look at South Africa, And yes, it is sometimes very surprising for people to see that when you compare our direct electricity prices with other countries, our electricity price is still very cheap. And we are much cheaper than Spain at 150 and China than like $75 per megawatt hour. So we must still count our blessings. We looked at preheating of manganese ores for manganese smelter in each of these locations. We did a lot of modeling to have a techno-economic model that can give us a capacity factor. First of all, you will notice that you need different amount of towers, different amount of infrastructure on location based on your solar resource. So for South Africa's really good solar resources, you need less mirrors, you need less towers, you need less thermal storage to get to your optimal price. And then you can calculate using a typical meteorological year, broken up in hours. You can actually estimate the capacity factor for your renewable energy system. What amount of the time is it going to supply you with your energy requirements? So here we had for China 63% of the time, for Spain 76% of the time, and for the South African locations at TransAlloys 63% and then 80%. So if this is with some thermal storage, so you can increase your thermal storage more, but your electricity renewable energy price, your renewable energy price is going to increase, and you will find less and less benefit for adding additional thermal storage. So this was optimized for lowest cost of thermal energy combined with a backup of grid electricity. So when we then look at the combination, you can see the cost of heating. So this application was for heating to 600 degrees Celsius. You can see that the cost of solar heating is lower in South Africa than in Spain or in China. Of course, it's highest in China because they had the worst solar resource in the location we were evaluating. And then for the electricity, this is the grid electricity price to remind you. And then for the combined system, because our grid electricity was our backup, you can see that this combined solar and grid electricity heating was cheapest in South Africa, and then in China, and then in Spain. The reason why it was cheaper in China than in Spain is because they had a lower grid electricity price. So when you optimize, they needed less capital for their solar system to get the optimal levelized cost. But when you look at comparing this benefit to just saying, okay, we're going to heat everything with electricity because my country is going to change the grid eventually and it's going to be 100% renewable, so I'll just electrify everything. You'll find that the countries with the most benefit was actually Spain, and that was because their grid electricity had the highest price. So in South Africa, for TransAlloys, they didn't have as good a resource as Hotazel in the Northern Cape. So the benefit for them to invest in a solar thermal system with grid electricity backup was about 5% to just going with a full grid electricity electrification option. Okay. But at Hotazel, when they had a great resource, it was almost 20%. And in Spain, where the grid electricity was very expensive, there it would really benefit them to, instead of looking at electrification of the process, look at a solar thermal combined with electric option for them. Okay. This is another case study I did very, very high level. We looked at the cost of process heat in South Africa at Aggeneys, which is a little town in the Northern Cape. You might be familiar with it as the Gamsberg zinc deposit. So when you look at the graph, and I express this in US dollar per megawatt hour, just because I was giving this presentation for the first time in America, you'll see that solar thermal heating costs can definitely be a benefit if you compare it to grid electricity costs and diesel costs. It is at the moment still more expensive than metallurgical coke or anthracite. So in the research area, we are trying to make it more competitive by lowering the price of the technology, but we're also trying to make it more competitive by raising the price of carbon. So yeah, there are different methodologies for calculating the levelized cost of heat. So sometimes it's difficult to compare things on a graph like this. I used the technology options of having a particle receiver and particle thermal storage. If you do the same analysis while using, maybe you have a lower heat application and you want to use solar oil for your heat transfer fluid and you're using molten salt as thermal storage, you're going to get different numbers. But in general, solar thermal costs can be from $50 US per megawatt hour to $50 US per megawatt hour in South Africa, based on technology and location. Okay, so when we looked at the Gamsberg site, we were looking at what could we maybe in future, just for fun, apply this to, and I evaluated using solar thermal energy for remelting the cathodes from the electrolytic zinc production to cast them. So this is purely melting zinc and casting it, and the alternative being the commercial induction furnace and the solar thermal plant. And you can read the whole presentation I put it on my ResearchGate profile, but it came out to about $35 US per megawatt hour cost compared to for the induction furnace, but I assume just the grid electricity cost. And over 15 years, solar thermal technology could result in almost 50% saving on energy costing for casting. And there's also some reduced CO2 emissions, which is sometimes more important to me than to the business who invest in the technology. It's funny. Okay. And I also wanted to show that you can then use your study to go and look at what is the area that you will need for this solar thermal plant to help do the casting. And there's an interesting graph there on the area required for 4 towers and heliostat systems. But I could find an empty spot on the Gamsberg site. So it is, in theory, it could work. I'd also like to mention we are making more research facilities available at Mintek. We are relocating the parabolic dish facility from Stellenbosch, pictured here, to Mintek, and hopefully once lockdown is lifted, we will be able to organize it to be moved to Mintek campus. And from next year, we will probably be starting to run blue sky projects on this, innovative receiver designs, integrating it with some thermal storage, integrating that with some minerals processing. We look forward to really testing the limits of our understandings of this solar technology in this system. And then please, we love to collaborate. I do think that one of the best ways to reduce your risk for climate change, for emissions risks, for any research challenge really, is to get the right partners to help you solve your problem. And then I'd just like to say we did plan the Renewable Solutions for Energy Intensive Industry colloquium in June in Katu. We I've now changed it to Cape Town in October. I hope that you will still register for it and watch the SAHIM events page for news and updates on the location. It will be co-located with the Manganese School. I'd like to thank a lot of people who helped me with a lot of the project work that I briefly presented here. It's all teamwork. We work together with international researchers, but I'm even more proud of my local researchers who help me. We get a lot done. Thank you for listening.
Thank you very much, Lina. I'm sure everybody else enjoyed it as much as I did. As usual, you delivered a very interesting talk. So we have a few minutes left before the hour is over, so I'm going to jump right into a few of the questions. One of the questions I'm going to combine two. There was a question if you could just recap on exactly what scope 1 and 2 and 3 emissions mean, you know, the definition. And then the question that comes following that is, the carbon tax, where applicable at present, is restricted to scope 1 emissions. Is there an intent to expand this to cover all the scopes, 1, 2, and 3, to further influence companies to consider their entire carbon value chain? So if you maybe just recap and then your opinion on that matter.
Yeah, so basically scope 1 emissions is what you do in your company directly. So it would be, it does not include the emissions from electricity that is generated on the grid. It does not include emissions from anybody else, only what you emit directly. It does include things like the emissions from the trucks if you drive something from here to there and you're burning diesel in your combustion engines. So it is the emissions that you occur in your usual business model. So when I say directly on site, it depends on the scope of your business. If you are transporting something, that transport emissions is also part of it if you do it under your business. You know. So it is a bit of that thing of where do you draw the borders, and that's sometimes based on the contracts you have with your suppliers or customers. But it is the scope 1 is what is directly under your control, and there's no denying that you are responsible for it. So that is undeniably yours. Scope 2 is adjacent to you in the value chain on the supply side. So it is also in your control because you can decide what you buy. Sometimes you don't have much choice, but theoretically you can always say, no, I don't want to buy that. So it is in your control. So when you look at scope 2 emissions, it's what you buy to do your business and to create your project. Then scope 3 emissions is what's emitted by the people that you sell your products to. So for example, if you are, let's take, if you are mining iron ore, okay, then scope 1 is what you do in mining operations, your trucks, your transport, and then you sell it on. You maybe buy electricity, that's scope 2, but you sell it on to somebody with a steel plant and they use carbon to smelt it and make steel, and their emissions is your scope 3 emissions. Okay, so I hope that cleared it up a bit. Then about where's carbon tax going? So yes, currently it's only on what's on your site, and currently if you look at all there's like 60% you don't have to pay carbon tax on, and then there's other things you can do to reduce it so that you in the end you're most likely only going to pay carbon tax on about 10% of your emissions. This is just the start. South Africa is following the European model on carbon tax. It means it gets eased in very lightly. And the plan is, and you can ask government about it, they admit it, the plan is that it will become more stricter as time goes along. So first they will reduce the free emissions, and once all the free emissions has been reduced, then they might say, okay, but let's increase this to scope 2 emissions. Now you will also have to look, yeah, but first they'll reduce the scope 1 free emissions, and when all of that is reduced, then they might think about scope 2, but that's going to be quite long in the future. Our government is very sensitive to the risk of hurting industry and then losing employment. It is a difficult balance to have to weigh the environmental imperative against the growth and the prosperity of the country. I am glad I am not that politician who's making that call, but it is going to get stricter, definitely on scope 1 emissions, but I think it will be appreciated by everybody who's climate aware if your company also takes note of scope 2 emissions and scope 3 emissions. So if you're planning in the long term, more than 10 years ahead, you would it would serve you well to look at scope 2 and scope 3 emissions and see what you can do. It would actually be, you know, for long term, these are the people you need to talk to say, can we work together and do something that's not possible for each of us by ourselves?
Thanks, Lina. There was a follow-up where I think you kind of answered. So the material inputs for scope 2 emissions, you know, like coal for a power plant is under scope 2. So the materials for electricity during coal power generation is under scope 2.
Yeah, so if there's emissions in the mining of that coal, that is the power plant scope 2 emissions.
Okay, thank you. There's a question here from William Manana. He says, good presentation, by the way. He says, how can CSP technology be competitive relative to other renewables in South Africa? How can we, say, accelerate this learning curve also globally, in your opinion?
Okay, so at the moment, you know, we've seen it time and time again. The more you do something, the better you get at it. So we've got some great technologies that's been developed in South Africa and internationally on the concentrating solar field. I can mention particle receivers. I can mention the heliopod technology at Stellenbosch University. The barrier we face at the moment is piloting and demonstration. We need to do it over and over again so that we can get better at it. In CSP, we are still, I think, on the learning curve, on a steep learning curve, because most of the time when you see a new concentrating solar project up and running, there's been a technical change to the previous one. There's no optimal technology yet. We are still trying. We're trying to see which pieces fit best with which parts. So we need piloting, we need demonstration. And that's not going to happen without industry interest, hence this presentation. But you know, we need to be led by industry. We can try and make something, but if nobody wants it, it's not going to be put into practice. So we have to be aware of that. And really, I've been part of the reason why I do some case studies and why I elicit funding for case studies that companies have not even asked me to do, is that I want to raise awareness that there are more options there than just the solar PV panel. And that sometimes a technology like concentrating solar has benefit over solar photovoltaic. One of the benefits is that the thermal storage options are generally much cheaper than electricity storage options like batteries. So, of course, once again, you have to evaluate it case by case, customer by customer, site by site. And that's one of the things that's slowing us down. But if we have enough researchers committed to that. And if we get interest from industry, that is really the thing that we want to get. That would help us to develop these technologies to applications. And then they will become cheaper, they will become more affordable, and it will be, I think, grow from strength to strength.
Thank you, Lina. I think one of the big takeaways from today that I hope people realized, and I think you said it nicely, is that we're not renewable, especially PV, is not just about electricity generation. We have lots of opportunities to use the heat, to integrate it into our processes, and none of these are simple solutions. We are still learning. And I think there was quite a few, there was 2 or so comments about the issues about policies, politics versus science, and the whole issue about the 2050 targets for carbon reduction. So I know we all know this is a grand problem. This is not a simple problem, but thank you so much for your time today. And I think your offer of presenting again is definitely gratefully accepted. There was also a lot of interest in terms of the hydrogen in metallurgical industries. Maybe that's a nice discussion topic for next time. So I see our hour is over. Thank you very much to all the attendees. I see there's a lot of great support and comments for your presentation. Again, thank you very much. I think we'll conclude for today on that basis. Thank you, Lina.
You're welcome. Thank you.